Our second goal in section 1.6 inverse functions is to determine whether functions are one-to-one. Okay, so what does that mean? To have an inverse, a function must be this word or set of words one-to-one. That is that f of a equals f of b implies that a equals b. Okay, what in the world does that mean? Okay, well, let me lay that out for you. That means that x does not repeat. Remember, if x does not repeat, we have a function. But it also means that y does not repeat. So when x does not repeat and y does not repeat, that means we have one x coordinate to one y coordinate, one y coordinate to one x coordinate. So what is the test to determine if a function is one-to-one? Well, that test is called the horizontal line test. So let's look at that. Horizontal line test. And it's exactly what you think it is. If you can draw a horizontal line through a function and it passes through only one time, then the function is one-to-one. If it passes through more than one time, then the function is not one-to-one. Okay? All right, so let's look at number 1, 2, 4, 3, 7, and 7, 2. So you could graph these points and you could perform the horizontal line test. Or you could check, does 2 repeat anywhere in another x coordinate? No. Does the 3 repeat in another x? It does not, nor does the 7. Now check the y coordinates. 4 does not repeat, 7 does not repeat, and 2 does not repeat. So this function is one-to-one. Let's look at example 2. We know that example 2 is a function. It passes the vertical line test. But does it pass the horizontal line test? If I draw a horizontal line through the function, I see that that horizontal line passes through more than one time. So this function is not one-to-one. Finally, example 3. It is a function, we know, because it passes the vertical line test. Let's see if it passes the horizontal line test. And it does. If I pass that giant horizontal line through there, it does pass. So this function is one-to-one. So what does it mean if a function is one-to-one? If a function is one-to-one, then it has an inverse. If the function is not one-to-one, it does not have an inverse. You need to write that down. If a function is one-to-one, it does have an inverse. If a function is not one-to-one, it does not have an inverse. So the horizontal line test is a way to test by looking at the graph. If you have a relation, you can look at the x coordinates and the y coordinates to make sure they do not repeat. But how do we determine if a function is one-to-one algebraically? So let's see. How do we do this? First, we set f of a equal to f of b and simplify the function. If a equals b, then the function is one-to-one and thus has an inverse. So let's look at example number 1. All right, so remember, we set f of a equal to f of b. If I plug a in here, I get 1 divided by a squared. And plug b in the place of x, I get 1 divided by b squared. Okay, how do I solve this? Well, it's a proportion, so let's cross multiply. When we cross multiply, we have a squared equals b squared. How do I reduce that? Well, I take the square root of both sides, and remember, when you take the square root of both sides, you come out with plus or minus a equals plus or minus b. And instead of getting A equals B, I have positive A equals positive and negative B, and I have negative A equals positive and negative B. That means that my A's and my B's, or my X's and my Y's, repeat. So this is not a one-to-one function. Let's try example 2. Again, f of A is A squared plus 3. I'm sorry, not A squared, just A. A plus 3 squared. F of B is B plus 3 squared. Okay? And then if I take the square root of both sides, again, I do get plus or minus A plus 3 and plus or minus B plus 3. But I have something's a little bit different here, and let's talk about what that difference is. On number 2, I have a domain. This domain says that x is greater than or equal to negative 3. Okay? Well, let's think about this. Remember, we just learned about transformations of functions. If I were to graph the parabola x plus 3 squared, you know that the plus 3 is inside parentheses, so it would move the graph 3 places to the left. 1, 2, 3. And here I am with my vertex at negative 3. X equals negative 3. Well, the domain tells me for this specific problem that x is greater than or equal to negative 3. That means I would only sketch the right side of the parabola, the right half, which means the positive side of the parabola. So that tells me that I'm only keeping the plus when I'm given the choice of positive or negative. So now I have positive A plus 3 equals positive B plus 3. To continue solving, we would subtract 3 from both sides, and we have A equals B. Remember what we said. If A equals B, then the function is one-to-one. Let's look at step C. Use the graph of a one-to-one function to sketch the graph of its inverse. You're not given the equation of the function, you're only given the graph. Now, is this function one-to-one? Yes, it passes the vertical line test. That tells me it's a function. It passes the horizontal line test. And you need to understand that this section right here is constantly increasing. Even though it looks slightly horizontal, it's constantly increasing. So in order to graph this, first, plot a couple of ordered pairs. I see that I have an ordered pair at -1, -1, at 0, 0, at 1, 1, and then I also see that I have an ordered pair at -2, -4, and at 2, +4. Remember what we learned earlier about the relationship of inverse functions. We learned that a given function, f, if it has ordered pairs -2, -4, -1, -1, 0, 0, 0, whoops, and I'm running out of space, so I'm going to skip to 2, 4. How did we learn that we can find the new ordered pairs? What happens to the domain of the function in the inverse, and what happens to the range of the function in the inverse? Recall that the domain becomes the range, and the range becomes the domain. Now, -1, -1 isn't going to look any different. 0, 0 isn't going to look any different. But 2, 4 will become 4, 2. So let's plot these new points. So -1, -1, 0, 0, and 1, 1 will remain the same. But -2, -4 becomes -4, 1, 2, 3, 4, -2. 2, 4 becomes 4, 2. And if you need more points further out, feel free to plot those. Now, I'm going to do my best to draw this on this not very user-friendly slate, so please forgive me if it's sloppy, but I'm going to do my best. Okay, and then, sorry that I missed the point. That does not look good, ladies. Okay, so there's the inverse, and remember, we try to sketch through that y equals x to check it. So if I plot y equals x, and on your paper you should see that y equals x goes exactly through the middle there.